Department of Computer Science, Faculty of Physical Sciences, Curie State University of Science and Technology, Adaru. So my presentation is Predictive Analytics in Breast Cancer, a naive-bias perspective approach. Okay. First of all, using breast cancer data set. Breast cancer is one of the most common cancer among women, and is the first leading cause of cancer-related deaths among women, and the second leading cause of cancer deaths worldwide. Why I get more interested in this topic in relation to the survival analysis, because presently from Nigeria, one of the largest African country, one of the largest countries in the West African continent. And this is one of the most challenging aspects among women. We are facing many women are dying seriously. So the things is getting out of hand. So that's why I get an interest in, okay, how should I improve from the previous project that was in existence to find out how just our medical doctors can be able to roll out the survival chances of the patients they have, mostly related to the breast cancer. So according to the 2012 World Health Organization classification, breast cancer is primarily categorized into carcinomas and sarcomas. And this classification is based on the type of cell they originated from. Carcinomas mostly arise from the epithelial cells, which line the organs on the body surface, while sarcomas develop from mesenchymal cells, which form the connective tissue like bone, muscles, and cartilages. The study focused on the predicting the breast cancer survival using naive-Bayes techniques and confused several machine learning models across the large data set of 310,000 patient records. The survival and non-survival classes were the two main categories. The objective of the study was to assess the effectiveness of the naive-Bayes classifier in data mining area and to attain a noteworthy outcome for survival classification that were consistent with the body of the existing literature. From what I learned that the previous literatures, most of the previous literatures I read about is they use Wisconsin data set, which by the comparison, they use a small amount of data. So that is why I increased my research with the huge volume of data, that is 310,000 patient records. The research question I wanted to address are number one, to identify the strengths and the weakness of machine learning models in handling complex medical data. Then second, the research significantly contribute by providing a stronger theoretical basis for the applications of machine learning in predicting breast cancer survival. Then thirdly, to systematically analyze the efficacy of different models by standardizing and validating various algorithms, thereby enhancing the reliability and accuracy in predicting breast cancer survival outcomes. Machine learning. Machine learning is a significant area of study within the artificial intelligence that deals with algorithms that use data to continually grow smarter with experience. The field focuses on prediction based on known properties learned from the training data sets. In this study, the naive Bayesian algorithm is being utilized for categorizing breast cancer data in order to determine the patient's odds of survival. The studies produce a positive results in terms of first, sensitivity, second, specificity, third, accuracy, then precision, and last, measures. The methodology deployed in the study. I downloaded the surveillance epidemiology and result data on the breast cancer from the National Cancer Institute of the United States of America. Okay. If you can see, this is the methodology deployed. First of all, the breast cancer data set. Then I did document analysis on getting the right source of the data to be used for the project. Then I went for the pre-processing. At the pre-processing, I used data cleaning, and then I trained the data. Then I run my analysis. But during pre-processing, I go into the integration, discretizations, and normalizations of the data. Then from the data analysis, I went to model selections where I did feature selections, and I went for the computational metrics. Then selecting my classifiers, then performance metrics and results. So the classifiers I use an IFBIS, SVM, that supports vector measurements, and KNN. Okay, so from this, from the graphical, from the picture I'm presenting here, is the scatter matrix plotted against the various variables that I use for the survival. Then the second is the correlation analysis, whereby I correlate a lot of the variables that I have during the analysis. So Zare created a split into the trained data set, and the test data set. Then a test set comprised of 70% of the data set, that is from the 310,000 patient data, with the remaining 30% going into the test data sets. After this, I said that then the features in the training and the testing are standardized using a standard Scala. So I use Python programming language. The function SKLN matrix, confusion matrix, is utilized to assess the effectiveness of the trained model by contrasting the expected and the actual class level. This is the value of the confusion matrix. Okay, 233, 679 against 153, and the other side is against 150,067. So the confusion matrix counts the number of the true and false prediction in order to assess the degree to which the classification system predicts the future. First of all, from that 233, that is the true positive, are cases that are correctly identified and analyzed, while the 679s, which are the false positive, are the cases that are incorrectly identified. Then the true negatives are the cases that are correctly rejected. Then 153, that is the false negative, are incorrectly rejected. Incorrectly rejected, that's 153. Then accuracy testing. After the confusion matrix, then I went for the accuracy testing. After passing the test accuracy value, we arrived the same value of the confusion matrix, which is the same. This is what I arrived in the confusion matrix, that is 0.948425. Okay. While the random forest classifier, the model result outcome is 0.95679. Random forest classifier is the class in the sklearn library of the Python that implement a random forest algorithm, which is an example method used for the classifications and regression task. After running the following test, this is what I'm able to achieve. Okay, so then I was able to test the three models: random forest, then logistic regressions, and decision tree from my data. So then under precision recall and F1 score, as I've said earlier, and I said that accuracy again are other things that I was able to test from the models that I was trained. First of all, random forest. Random forest perform a better for both classes compared to logistic regressions and decision tree with the value of 95.68. And so therefore, my comment is the most balanced and accurate model among the three. Then the logistic regressions with the lower precision recall and F1 score of 94.89. The last, which is the decision tree, with the lower precision recall with a 93.42. which is having the least accuracy and the balance, especially for zero class. So uh, from this, I was able to deduce the following informations. For the random forest logistic regression and division tree, this how it was presented. Then the accuracy. Okay, then I went for the algorithm that I tested, that is the naive Bayes, KNN, and SVM. The k-nearest neighbor algorithm, this is their values. Then naive Bayes, and support vector machines. Okay. If you look onto the accuracy, support vector machine has 0.25% of the mean accuracy. Then naive Bayes have 0.4. With the nearest neighbors algorithm has 0.36. So based on the mean accuracies, the SVM model appear to perform the best among the three algorithms, followed by KNN and naive Bayes. So improving the naive Bayes. So after having those values, then I think that, okay, since my topic of interest is naive Bayes, how can I improve the naive Bayes? So to improve the performance of that, the accuracy for the survival of that naive Bayes, then I use AdaBoost. So after using the AdaBoost classifier in the sklearn, one way to build the example of the weak naive Bayes classifier is to use the AdaBoost algorithms, which attributively trains the weak classifier, combining their prediction to produce a stronger classifier. So after passing the naive Bayes, I was able to attain the mean accuracy of 0.311 with a standard deviation of 0.32. So the lower mean accuracy suggests that the other boosted naive Bayes model in its current configuration does not perform well as expected on the given data sets. The high standard deviation indicates the inconsistency in the model's performance across the different forms, which might be due to the complexity of the data sets or limitations in the base naive Bayes models. So from this, I deduced the future research, which will focus on the incorporations of the new method into the current models of the prediction survival, along with extending the research in other dimensions. Therefore, this gives the rooms for the improvement, especially in accurately identifying the instances of the class 0. Okay, thank you. That is the end of the presentations.
Thank you. And any questions from forum?
Do you have any questions, Carlos?